Hey there, this is Akshanandan and welcome back to a new video. And this video is going to be important and interesting, I would say, right? Because nowadays, you know that things are changing very fastly in the fields of AI, right? Every day new things are coming, and every startup, every company wants to adopt AI in some form in their products. So that's why in normal interviews also for software engineering and software development, AI is getting asked, right? That's why I want you to understand the whole architecture of an AI application, right? So in this video, we are not going to talk about that go ahead and use OpenAI APIs or go ahead and use Gemini APIs. I already know that you can do that, right? But in this video, we are going to understand how companies actually use AI in their applications, how they communicate, how they build such an architecture which can communicate between your AI model, then your server, then your front end tech stack, right? That we are going to understand in this video, right? Plus, I'm also going to give you all the tech stacks that you should learn to build standard AI applications using this architecture, right? I have already built videos on various ways through which you can build AI applications. Plus, I've also did a video on what are the advanced AI projects that you can build when you're in college or when you are even a fresher, right? So let's go ahead. So first of all, AI applications are not very different than normal applications that you make, right? Using front end and back end. So in AI applications also, you have one front end layer and you have one back end layer, right? But what happens is in these AI applications, or even you take blockchain applications, or you take AR VR application, one third component also comes into picture. That third component in case of AI application is your model, management, and deployment, right? This is the third thing that comes into picture. In case of blockchain application, you have to think about the smart contract. In case of the AR VR application, you have to think about your rendering of your 3D models, where should be rendered in Unity 3D and all that, right? So that's why when you build these complex application which needs like AI, blockchain, and AR VR, there one third component also get added on top of front end and back end. I hope this is clear. Okay, so in this video we are going to see the two main architectures that are being followed nowadays to build AI application, right? So let me put the topic: AI application arcs, that is architectures, right? So there are two ways, and before that you also need to understand the components of front end, back end, and models, right? So in every mobile application or in every web application, desktop application, or like smartwatch application, there are going to be three things, right? One is your front end. Let's say this is a mobile app. Then it will be your server, that is your back end. And one third thing also is there, that is your AI model, right? So this is your app or your front end, right? It can be mobile. Let's assume it's a mobile app, right? Then your next component is your server, that is your backend, and last is your AI model. Okay, these three things are there, right? Now, the two ways which I was talking about, the first way is if you have your AI model embedded in your front end itself, right? And before I start teaching you this stuff, you have to understand the client server architecture. You should be clear with what is backend, what is front end. So just you can skip this part, but just don't skip it, right? So let me show you. So in every software you have one client and you have one server, right? You have a client, you have your server. So a client makes a request to the server and a server returns a response to the client. And at the backend, this server can be, communicating with database, right? It can be communicating with the database. It can be communicating with a, let's say, AI model, right? Anything it can do. It can be communicating with a model. It can be communicating with a smart contract in case of blockchain application, right? Anything. So server can do anything. Smart contract, right? So these are just the external components which can be attached to a server. But at the end, this is the client server architecture. This is your front end. This is your back end. Front end can be mobile app, web app, desktop app, smartwatch app, right? Server can be it's just a normal computer which has certain code written on it, and it just run those functions. It just performs those functions, right? Just an example. Just let's say I'm building one e-commerce application. So let's say Amazon. So the client is your mobile app, the Amazon app, which user can use to communicate, right? User can use to do something, place a order or see the products, right? That is your client. That is your front end. Server is the thing that scales up, right? Or that takes the orders and puts those orders in the database. Or server is responsible for making the secure payment transactions, right? So that's all is being done by the server. So server is like your brain, the major brain, and client is like your skin that users can touch and feel. Okay, and most of the complex logic is written on the server itself. So this is how this client server architecture works. Hey guys, don't forget to check out my own app, Resume Pal. It is the best app for last minute interview preparation and placement practice. So on our mobile app, you're going to get a lot of features like resume building, resume analysis, thousands of flashcards. But on our website also, if you click on the placement prep tab, you can actually practice by skills or by the companies. So if I click on any company, let's say Atlassian, I can actually see how they hire, what are the interview processes. Then I can see the interview experiences, like what was the round, how long it was, what was the difficulty, what were the problems that were asked, right? Then you can also check out the salaries which this company pays and the benefits. So this is an amazing application and an amazing website. So do check it out. It will be really helpful for you. Now let's get back to the main topic. So front end is your mobile app, let's assume. And this is your server, the brain, the AI model, which is a add-on that we have to attach to either the front end or to the server, right? So what happens is, in the two architectures that I told you, in the first architecture, this AI model gets embedded in the front end itself. Okay, it is embedded in the front end itself. So something like this, right? What do I mean by embedding? How to do it? I'll come to that. But in the first architecture, you have your AI model in the front end itself, right? So this will become my first architecture. In my second architecture, what you have is, you have your server connected to your AI model. So this is your second architecture. Okay. Now here I told you that AI model is embedded in the front end in some form. That means model file is in the front end code itself, in the project folder itself. But here the AI model is not inside the server. It is a standalone server. It is a standalone service, and our main app server communicates with the AI model server like this. Where it is hosted, where it is deployed, everything we'll talk about slowly. Okay. So these are the two architectures. In the first architecture, AI model is in the front end, and in the second architecture, your AI model is attached to a server. Now the question is, why are we even doing this? What is the need, right? So there are certain points that you have to answer. If the interviewer asks you, like, why are you explaining me these two architecture? So these are the points. Why do we have to, bifurcate these two architectures and when to use what? I'll give you the answer. So the answer is, just remember these 5 points. One is latency. By latency, I mean that if your app or if your user expects the results very quickly, right? Then you need lower latency in your application, right? Then you cannot afford the time that is spent here, right? The communication between client to server, then server to AI model, then AI model to server, then server to client. You cannot afford that, right? Let's take an example. Let's say you are building an application where you have to, in real time, you have to detect whether this is a cat or a dog, right? Using the camera. So there, when we are talking about real time, that means camera is on and you want to see the results, right? So there you cannot have like loader, and you can expect the results, right? User will be irritated. So there we want lower latency, right? There we want lower latency. So in that case, it will be very much better if you just put the AI model in the front end itself, in the mobile app itself, or in the web app itself, right? Latency. Second thing is, so in this case, if latency is expected to be lower, use this architecture. If latency is expected to be it is okay if it is higher, just go through, just use this second architecture. Okay. Your next thing is complexity. If your AI model is too complex, right? Let's say it is a GAN, generative adversarial network, right? There you have to generate the images, you will be needing some GPU power, right? So that time your model can be too big also, and it will be very complex also, right? So there you cannot put that in the mobile app, right? Because in mobile app you don't have like a dedicated GPU, right? For that you need a dedicated GPU, and that you can find it in the server in the backend itself, right? So if your model complexity is higher, then use the second architecture. If your complexity is too lower, right? Like in the cat dog detection, that's just like 0-1 prediction, right? There you can just go with the first architecture. Okay, let's take the third point, model size. If due to some reason the model size is too big, let's say your model is like 1 GB, that time you cannot put your model in the front end, right? Because if you are putting your model in the front end, in the mobile app or in the web app, then these app sizes will also be very big. Nobody will download the 1 GB or 2 GB app from Play Store or App Store, right? So that time you cannot do that. Or if you put your model of 1 GB size in a web app, then it may take like 10 minutes to load the website, right? There you cannot do that. That time also, if your model size is too big, then go ahead and put it in the server itself. Okay. Next point is sensitivity of data. Sensitivity of data. Now this is quite controversial. If your users, the data that is being generated in the app is too sensitive, then you have to, it will be recommended that you just put the data in the mobile app itself. You don't send the data to the server, because in this communication, because at the end what is happening over here, this is a front end, this is a AI model, and at the end you have a server here, right? You have a server here, and over here what is happening, you have a mobile app here, or you have a client side here, right? And at the end there is a request response APIs, REST APIs that are there in over here, right? So what is happening, your data is going to go from the front end to the server, right? There you cannot do it because your data is too sensitive. Privacy concerns are there, right? So it will be recommended that you put the data in the mobile app itself and you don't transfer the data, right? Because hacking can happen, like anything can happen. But there is another point. Let's say your mobile only got stolen, right? And because of you did not encrypt the data somehow, and your mobile only got stolen, then the data is also gone. Okay. So that's that time also. But in the case where you are just generating the data and just deleting it, that time it is okay because you are not storing any data. That is totally fine. But in that case also there is one point, right? So here you have to think what is happening in your application. If it makes more sense to just store the data in the server securely using encryption algorithms, use the second architecture. But if you are just using the real-time generation and you have privacy concern, your data is sensitive, just go ahead with the first architecture. Your last point here is model management. Let's say you are building such an application where, you are building such an AI model where continuously in months you are updating the AI model weights, right? Or you are putting more and more data into the AI model for training, right? So there, what is happening? Your AI model is continuously getting managed or maintained, right? So that time you cannot put your AI model in the front end, because every time you update the model, you have to bring an update to the Play Store and App Store, right? So that time you cannot put your model in the front end. That time you have to you have to connect your AI model with the server itself so that you can directly update in the backend and your users don't face any issues or a blocker, right? So this is also one important point that should be kept in mind. So these are the 5 points that actually decide whether you should go with first architecture or you should go with the second architecture, right? Both the architectures have their own pros and cons, and they are used at a lot of rate. It's not like that this architecture is used the most or this architecture is getting used the most, right? Both of them are getting used. This is mainly used when you want to deploy your AI model in the edge device, like in the washing machine or in the like directly in the mobile device or smartwatch. That time this makes more sense. And here, this one you use when your models are too big, like ChatGPT, like OpenAI, right? Or like Gemini or Llama, everything. Llama is a model, but OpenAI APIs and Gemini APIs they are doing what? They are doing this exact same thing. There, this architecture is getting used because you are the client. You don't know which AI model is used. You don't know where the model is located, where the model is deployed, which model, linear regression, logic state, whatever it is used, you don't know, right? So there, the server, that is OpenAI server, has the AI model deployed somewhere, which I will be talking soon, deployed somewhere, and they just give you the APIs, right? They just give you the endpoints that, hey, this is the endpoint for chat, this is the endpoint for generation, this is the endpoint for whisper, right? They just give you the endpoints and you directly communicate with these endpoints. So there, this second architecture is getting used. Okay, nice. Now let's go ahead and understand how can you actually embed the AI model in the front end, or where to deploy your AI model, how to deploy your AI model, right? So over here in the first architecture, what is happening? Let me just copy this whole thing. This we don't need, this you already know. So what is happening in the first architecture? You have your mobile app, you have your web app. So let me also write down the tech stack so that you have like proper roadmap, which tech stack you have to learn, right? So for the mobile app, what you're going to do is you have Flutter for mobile app, React for web app, React Native for again mobile app. You have Ionic for cross-platform. You have Xamarin for cross-platform. You have Cordova. You have I think this much. Angular. You have, right? Many front-end libraries are there, or packages are there, or SDKs are there that you can use. You have Swift for iOS, right? That you can use to build your front-end applications. So this front-end will be built using these frameworks, okay? Then AI model. For building the AI model, traditional libraries, Python libraries, you have your PyTorch, you have your TensorFlow, then you have your scikit-learn, NumPy, Pandas, all the Python libraries, Hugging Face you can use, to get the models. I'm not talking about building the model, I'm just talking about getting the model transformers, when you just plug in some components. So a lot of libraries are there, mostly Python, written in Python. You can use these libraries and packages to build your AI model, right? So we can say that this AI model component will be made using these libraries. Now it is the point where you have to embed your AI model in the front end. That how will you do, right? So for that, even you build a model that will be at least in like MBs, right? 100 MB, 200 MB, right? For normal prediction model also. There, how to put that model in the front end, because even 200 MB is bad. So what happens is there is a library called TensorFlow Lite, right? Let me write it down. TensorFlow Lite, or TF Lite is called. It is available in Flutter. It is available in most of the famous front-end frameworks, right? So what happens is this library, when you are making the model itself, you actually take your model and pass this AI model to this TF Lite library, and this TF Lite actually gives you the lighter version of your AI model. AI model Lite. This gives you the lighter version of your AI model. So what happens is now this model Lite is in like KBs, or like 1 MB, 2 MB, 10 MB max, right? How does it do it? That's actually mathematical. It uses quantization or something like that, where it actually reduces the dimensionality of your weights, right? Let's say your one weight, if I'm boring you, you can skip that, but let's say your weight number is 0.0002134678910, something like this, a very long number. Then this fine tuning and all of these techniques, they reduce the dimensionality, right? They reduce the size of that number. They will just make it 0.00213. That's it. So yes, prediction is affected a bit, but it is, nobody will actually notice it, right? So you have to do these kind of trade-offs. So these libraries will actually give you a lighter version. Now you can use this lighter version in your mobile app. Over here, right? Over here you can use this lighter version. This is just like a normal file, right? Your Flutter code or your React code will give input to this file, and it will just give you the output back, prediction back, right? Like your mobile app will give it an image, and prediction will come back that, hey, 0, that means dog, 1, that means cat, something like this, right? So this is your architecture, and this is how you build it, right? In the next case, where is a server, what is happening over here is, let's just copy this also. So in case of this architecture, again, your server can be like in Node.js, it can be in Spring Boot, it can be in Rust, it can be in Go, it can be in Python. Python has many frameworks like Flask, it has Django, then you have Fast API, right? Many backend frameworks are also there. So your app server can be built in any of these architectures or any of these libraries or packages, right? But most of the cases, in case of AI application, Fast API, Flask and Django are preferred because they are also in Python and your AI models are also written in Python. So most of the companies don't prefer hiring two different types of developers. They will just hire one Python proficient developer and who will build the AI model also, who will just build the server also, right? So that's why most of the startups are preferring these three tech stacks for building their app servers, right? Now it is the chance when you have to deploy your AI model. So AI model, you have like various cloud platforms. So AI model is usually deployed on cloud platforms. So it is your Azure ML, right? It is your Google Cloud, Azure ML, it is your GCP, it is your AWS SageMaker, which is a service from AWS, right? These are the three major cloud services, platforms which provide various services for AI model deployment, management, and hosting, right? So these AI models will be deployed, they will be built in the same tech stack, these libraries only, right? But they will be deployed on these three cloud platforms. So what happens when the client comes up with a request or a dog image, gives to the server performs some computation, gives the model, gives the image numeric matrices to the model that is deployed on a cloud service. Model predicts, gives it back to the server again does something, it stores it in the database, gives the data back to the client, and hey, client is happy, got the prediction, right? So this is how the architectures are there for AI models, right? So these are the two ways through which you can actually create your AI apps, standard AI apps, as the AI companies are using and they are building. So if any interviewer asks you like, hey, how are you going to contribute to our AI model app, right? AI application. You can tell that, hey, I have worked with these two architectures. I have built some projects in this. So yes, projects are very important. Build some projects using this also. Build some projects using this architecture also, right? Put them in your resume and you're good to go. So this is it, guys. I hope you enjoyed this video, this lecture. And don't forget to check out Resume Pal. It's an amazing app for placement preparation, last minute interview practice, in resume building, resume analysis. Plus, we also collaborate with colleges. So if your college is interested to collaborate with us, go ahead and refer us, right? So till the next video, keep coding, keep innovating, and thanks a lot.